Perfect. Yeah, hello everyone. My name is Margarita Skoryi I'm from the German from the German Meteorological Service, and I will be presenting you the urban heat island maps that we created and how land cover changes are included in them. So let's start. As of now, if you see to your left side, there's a map of the currently used urban climate station pairs that we operate. It's seven of them. Actually, as of now, it's eight. And they both include a rural station, which is outside of the city, and an urban station. And as you can see, the situation now, we have only punctual data and spatially limited data. And the aim of the project was to be able to provide a map of I specified canopy layer urban heat island information. And also the aim was with rising awareness towards climate adaptation and mitigation strategy for municipalities to provide a free source of information that they can base their decisions on or assess already developed land cover changes in the past. So this I pointed out two pillars that the method is based on. So first one is the Hostrada dataset, which is like if you translate it from Germany, it would be high resolution hourly raster data, which includes 13 variables with an hourly resolution from 1995 to 2022 as of now, and is wanted to be updated on a monthly basis. The same temporal resolution and also the spatial resolution of 1 kilometer is aimed to have is aimed to be the urban heat island maps too. And the whole data set is a combination of weather station data, satellite data, and modeling data. In this case, for calculating the urban heat island maps, what is important is the wind speed data, which will be derived from model data, and the cloud cover data, which will come from satellite data. And the whole raster data set is a successor to the test reference years basis data, which only have a time range from 1995 to 2012. So the second pillar, let's call it like that, are the land cover layers, which we get the Korean layer from the Copernicus program, and currently they're updated every 6 years. Have 44 land cover classes, 11 of them are urban classes, and we use the raster data with a resolution of 100 meter. And both of them together will provide us the online service that we call UHI-Map, or UHI-Map. So this is the basic equation that we use for calculating the UHI, which you see on the left side, the actual UHI, which is dependent on a maximum value and corrected by several factors. Here, as I mentioned, it's the wind speed and the cloud cover, both the 24-hour mean before the time t, and daytime and year time dependent factor. So first off, we need the UHI max, which is dependent on which we use this formula for, and you can see one thing is missing is the population, and what we want here is the population that is represented by that represents the building intensity, so not the actual population value. So next point that we're missing is we want to calculate the population value, and this is where the Korean land cover is coming in. We have the table on the left side where all the urban classes, 11 of them here, are assigned a UHI index. And this index represents the the ability of this land cover class to heat up, let's say it like that, and this index ranges from 0 to 1. Here on the right side, you see the city of Aachen, the grid cell where the city of Aachen is. And what we did, we did a circle with a 2.5 kilometer radius and saw, okay, what land covers are there. And we assigned all the values that are in the table here to all the land cover classes that are there. So this is the, let's say, the translated plot. And what we have now is a lot of spatially distributed indices. And for the calculation of the population, we average all the values that are in there. So we have this huge I potential with which we calculate the population, and thus in the end we will have the huge I max value. So what is still missing in the equation is dependency on the wind speed, cloud cover, and daytime. As you can see, on the vertical axis is the correction factor, which has a range between 0 and 1. And with increasing wind speed and increasing cloud cover, you can see it as expected. It goes down. And regarding the daytime dependency, here is displayed for June. You can see the factor goes against 1 during the nighttime, and around midday it goes towards 0. So now we have all this data. The point is now, how good is it? And for that, we compared the data that we have from the data set with measurements from here selected cities, Frankfurt and Munich. And first, I want you to focus on the lower left diagram, which is the average diurnal cycle of the 2-meter temperature for Frankfurt for both for the stations and the model, or like the data set data. So the both lines that are in yellow are the ones from the urban station, the one in black are from the rural station, the one with the dotted line is from the weather station measurements, and the one with a straight line is from our calculations. And we see here for Frankfurt is quite a good fit. We did the same for Munich. And what we see here is there's still during the nighttime overestimation of the huge I, and that's what we also want to assess. Like, why is there a perfect fit for or like a good fit for Frankfurt, and for Munich is a bit less. So we now see how good our data is. So this online service, we don't want to put online the hourly data because it's a lot of data, like for this whole time frame, and for 5 different line cover layers for now. It will be downloadable otherwise, not here. So for this online service, we put online 3 products, which is the maximum huge I, the mean maximum huge I, which will be available on a monthly, per season basis and per year for the whole time frame. And there will be an additional product that we call Delta Tropical Nights, which is the calculation of the tropical nights from the temperature layer and the calculation of the tropical nights from the temperature layer minus the UHI effect. So to have kind of a reference, how many tropical nights could this grid cell be reduced if there wouldn't be any urban structure? So yeah, this is kind of a preview of the upcoming online service on the left side, and you will be able to choose on the left side your time frame, the product that you want, and different background layers. On the right side, you will see some quick analysis here. For example, the Korean land cover development for each selected grid cell, like not an average for whole Germany, but you will be able to select each grid cell and see it there. The same will be for the selected product that will be shown to you. We will be happy to have a beta version online by spring next year. So that is the plan for now for this project. And as you can see now, this is we did this for Germany, but we plan to use other input data that cover like a bigger area around Germany. So that is the next plan of the project. And thank you very much for your attention.
Thank you, Margarita. Perfect time. And thank you for the insight for a new calculation of the image effect. Questions from the auditorium?